Hi, welcome to the Big Bang of Data Science. I'm Dr. Denise Dahman. In this video, I'm going to walk you through the element of the second edition for the Big Bang of Data Science. If you have completed the first edition, you may wonder what is next. This video is going to share with you the outlines of the main element that is planned to be covered in the second edition. Let's get started.
Now, essentially, the focus of the Big Bang of Data Science in the second edition is based on what had been accomplished in the first edition. So in the first edition, basically, we were actually striving to create this kind of a product, we call it in general, which actually have three important attributes in the past and then the present and finally the future. And we said actually this product is going to be intelligent. We need to create or turn that module into some sort of a different form. This is where we suggested the fourth element of the Big Bang of Data Science in the first edition to turn this module into a sort of a GUI. But that was another option, a hardware device that actually utilized the model. So in this second edition, our main focus or target is actually to implement the model on a device, so to speak. This device will then be quite a bit intelligent in one way or another. And from academic perspective, programming a device to execute certain function, it's the field of embedded system, or more precisely, it's called the software engineering. And if you, of course, you get back to the essential logo of the Big Bang of Data Science from the very beginning, you will see this is the fifth element inside the entire book, that is embedding system. And that's exactly what we're going to be focusing on. Now, to do that, there are certain skills that we have to master. First thing, maybe we have to work on a certain programming language. While in the previous edition, as you have seen, that we worked on Python to create those modules and prepare them and package them. And then also the GUI itself was actually based on that programming language. But this is the case when we are working on a GUI. But with a device, well, the machine, we are touching the hardware directly. This is where we need syntax of programming language that is working on C. Also, in addition to that, we'll be focusing on learning some basic of electronics. Then after that, we're going to be starting implementing what we have done in the previous two steps to actually work on some sort of microcontroller. So perhaps we'll be starting Arduino. Well, the Arduinos are actually most of the commercial system, to be honest. They will not be using Arduino. It's a great for self-taught only embedded software engineering for two reasons, in fact. First of all, it will provide us with a nice abstraction layer to some of the most advanced embedded system topics. And therefore, it's easy actually to learn and as a bare bone, so to speak, microcontroller systems. Also, it has a very large community in case we need to consolidate if we face any problem. The fourth, maybe important element we're going to be focusing on to move from this trial or cartoon stage of using the Arduino, maybe to work in a real microcontrollers, is where maybe I will be most likely working on some sort of STM32 microcontrollers. So this is basically the features, the outlines of our first focus in the second edition of the Big Bang of Data Science. However, I'm going to bring a completely new branch also of discussion on the second edition, and that is to discuss quantum computing. Well, basically, quantum computing is the new phenomena. It's what everyone is talking about. It's a kind of a multidisciplinary field comprising aspects of computer science, physics, mathematics, which utilize actually the quantum mechanic to solve complex problems faster than classical computers or traditional way of constructing computers. And the field of quantum computing actually includes hardware research and application development. And in general, I could say that quantum computers are able actually to solve really, according to the theoretical at least idea of it, certain type of problems faster than classical computer does by taking, of course, the advantages of the quantum mechanical effects, such as maybe superpositions and quantum interfaces, etc. Now, some application, here's the point, where quantum computers can provide such a speed, boost include like machine learning or optimization problems and simulation of physics systems, eventually these are going to be a great kind of solution. So perhaps my discussion in the second edition is not going to be really a practical one, but will be a theoretical one. The reason, because this phenomenon is still under massive investigation of R&D. There are available, of course, some free access tools that where you can utilize some quantum computers to do the new phenomena of programming on it, etc. But still, I could say it's still a very early stage to speak about it. Maybe we need couple of years until it's really available in the market for production consumption. But it's not a bad idea that you really master the idea, at least from theoretical perspective about it. Of course, we will be also implementing some maybe applications using some programming advances on it, etc. But the point is that what I'm trying to say here, if this phenomena happened to be true in a few years, you'll see that the entire mechanism of actually our understanding on dealing with traditional computer is going to change. Because in the traditional way of dealing with these kind of devices, let me say, or machines, it was based on analog and digital phenomena, right? Whereas the digital was the easier way to deal with signals from 0 to 1, from 1 to 0. But with the quantum computing, this entire framework will change. And as a result of that, the idea of programming itself, such as, for example, using, if we're talking about higher level of using Python as a programming language, is going to change. Or even machine language like the C programming here we are using to talk to the device is going to again change. And as a subsequence of that, even designing maybe an AI module, it will be basically the core principle will stay the same. Nothing is going to change. Math will not change. But maybe the idea of writing your code or algorithm is going to change because the quantum computing, the way they compute it, quite a bit different. So to this end, I'm going to dedicate a large portion of the next edition of the Big Bang of Data Science on this subject of quantum computing. And to this end, there are a few skills that we have to actually be familiar with. First of all, the math of that, because the quantum computing relying massively on one particular branch of mathematics, and that's probability. Maybe the next important things also to master or revisit some important subject of physics, because the phenomenon of quantum computer emerged from that department. Of course, computer science in general is going to be some important terminology will be added, I do believe. In addition to that, I think, and this is the very, very important part, is to talk about the molecular physics, where in this we are going actually to focus on the idea of molecular in general, about how these subatoms actually were the actual investigation on establishing such a phenomenon. And in order to understand this quite clear, it means your knowledge of chemistry have to be there. That's why our focus on the subject of chemistry and revisiting some basic chemistry, such as maybe at least the periodic table, etc., is going to be mandatory important, because those quantum computers are actually built based on our understanding of chemistry in general. So this is the second important portion of focus on the Big Bang of Data Science on the second edition. To recap, I do believe once you carry on the process of following up from the first edition to the second edition, our slogan that take you from academic to industry is going to be real. Because over this path, you could see that you have mastered the idea of research and the analysis part and prediction of creating a model. Of course, you coded the GUI, and now you are able even to create an embedded system. And then you have a strong, ready information if the new phenomenon of quantum computer is really going to invade the market in upcoming few years.
I hope by now you have a very clear idea on every element and outline that are planned to be covered in the second edition of the Big Bang of Data Science. If you have any suggestion or question, please do not hesitate to let me know. Make sure to check the official documentation of the project in its official website. Until then, I look forward to your participating in the next edition of the Big Bang of Data Science. Stay good. Cheers.